Get started. I just started the recording. Welcome to tonight's New Paltz Climate Smart Solutions Meetup. And we do always try to emphasize the solutions. Tonight we have Joe Londa, and I've been excited about having this meetup for a while. Joe is a recent retiree with a 40-year career in electronics and information technology. And I love how you just jumped in and joined the Climate Smart task force back this summer. And as soon as I learned more about your background and your interests, I thought you would be a wonderful addition to our task force. And not only that, you were willing to jump in and do a meetup right away. So gratitude. You had said that after many visits to New Paltz, you decided to relocate here in 2017 and built a net zero energy, fossil fuel free Energy Star certified home. And I think that's what many of us aspire to. So I know everyone's real excited to hear what you have to say. You certainly, I know that you look forward to leveraging your recent building experience and your system science background to make a strong contribution to this task force and to New Paltz, and you're already doing that. Joe has stepped up to help us revamp our community greenhouse gas emissions inventory, which is going to be a big job. So without further ado, I'll let Joe jump in and add any other words of introduction, and reminder, if you haven't already popped in your name and a location into the chat, we'd welcome that. And we will have lots of time for questions and discussion at the end of the presentation. So with that, I'll let you take it away, Joe.
Thanks, Janelle. I have to say, I am kind of excited to give this presentation. It's the first time I've ever told this story. And it's a story that basically came together over about 5 years, actually. And it began with the notion, hey, someday I'm going to retire. What would I like to go do? And where would I like to go do it? The New Paltz area is a great area because of its of what it has here, the natural resources. The area itself is a beautiful area. The people are friendly, and it is just from an atmosphere perspective overall, it's just the kind of place that seems to be comfortable for me. So we set about trying to find a house, an existing house, and we looked and looked and looked, and we were not finding what we wanted. And so we came to the conclusion, okay, let's build a house. Because we found land that we liked. So we decided to commit ourselves to building a house. And so this presentation is the story of what we built and what were our goals in building it. And let's see if I can get it to present. Can you confirm that you see my screen in screen share mode?
Yes, we can see it just fine.
Great, great. Okay, so as I said, this is the first time I've given this presentation. I created this little pictorial to kind of get everyone to think about the fact that a house is actually a system, and systems have things that come into it and leave it. So I think of it as, well, what are all the things that come into a house, and what are all the things that exit a house? And if you think about it, it's surprisingly a lot of things. If you think about all of the different things that come in, that have to come into your house, the things that you use and the things that you put out of your house, it's a long list of things. And the icons here kind of deliver that message. I hope that we can be a bit interactive. If you have a question as I'm presenting, go ahead and ask it. If it's a question on one of these topics, hold it till we get to that topic. But let's try and be a little interactive. For time management, if I need to, I may put the question off to the end and we'll take it at the end. But let's see if we can be as interactive as possible. So I'll talk a little bit about the goals. How do you design something to standards, and what's your starting point? We got to think about the climate that we live in. Then I'll move on to the envelope of consumption, which is really one of the most critical parts of building a net zero house and a fossil-free house. And then you begin to move into the systems. So the electricity, the heating capabilities, what kinds of fuel are you going to use? And then I start to take a turn towards other things that are important, or so that they're certainly important in how we live today, and they're part of a house. So the internet, of course, automation. How much automation do you need in a house? Water is pretty fundamental. How much do you use? We'll talk about that. Food and other stuff, lots of stuff to build a house. And then all that stuff, some of it becomes waste and some of it is recycled. Finally, I'll just talk about metrics. And I'm a big believer in metrics because it helps us understand how we're doing. And then just a few closing thoughts and an opportunity for Q&A. So why don't we get started? And, four basic goals. Once we decided that we were going to build, we said, okay, well, we want to create something that's aesthetically pleasing. The style is what we'd call a farmhouse modern design. But it's also larger than perhaps what we needed at this point in life, because we wanted to be able to also run it as a B&B. So it's physically larger than perhaps what we needed. So it was part of our goal to create this lodge, so that other people could learn from it. What goes into a net zero house and a fossil-free house, but also to connect people with nature. That's part of our mission. So it is optionally as a B&B. We think next year is when we'll begin to operate. When we say net zero energy, we say that in the course of a year, because when you have solar energy, of course, during the winter, you don't produce as much electricity, but you do consume a lot of electricity. And then during the summer, you produce more electricity than you use. So for net zero, you have to look at the course of the whole year to see if you're going to be net zero. Eliminating the use of fossil fuels is actually not so difficult if you're making all the new decisions about what systems to put in. And you just have to be aware of, hey, what are the new systems that are out there that don't burn fossil fuels? Finally, the last goal was, it's possible to create a very highly complex system, a house, if you're not careful, and it actually can overwhelm you. So we were kind of careful in how many different technologies that we use, and we actually didn't do some things because they were complex and they really didn't contribute very much. So we took some things off the list. The last point that I just want to make about on the goals is the word aesthetically. Aesthetics is a funny thing. It will cause you to do things that aren't particularly efficient. For instance, you may have a view outside, to the outside, that's a great view. And to exploit that view, you'd put in an oversized window. Well, every window you put in a house is basically a hole in the house. The windows are terrible in terms of insulating, even if you use really, really good windows. Compared to the wall that you just put the window in, it's really poor. So we make these decisions, these aesthetic decisions, and they often will take away efficiency from a house. But that's the reality of how we live, right? We don't want to live in just a great big foam box. We really do want it to be aesthetically pleasing. And you have to have some trade-offs along the way about, what's important to how you want to live and the other goals. So that was just a comment that I wanted to make about how aesthetics sometimes causes us to do inefficient things. So to be efficient, you have to begin by sort of leveraging some natural efficiencies that exist. So natural ventilation, if you can see on the picture, and it's a small picture on the left, there's a cupola. And the reason why cupolas exist is because they give you lots of natural ventilation. Heat rises. If you open the windows, and we can open those windows in the cupola, the heat will move through the house, out of the house, and you'll get a lot of good natural ventilation. So take advantage of some of those things. It's a two-story house. So when you heat the first floor, the heat will rise and you'll get the benefit on the second floor. If it was all stretched out, you wouldn't get all of that benefit from the heat rising. And finally, we did not build a basement. We have a concrete
Joe, you've muted, I think.
up the heat and retain that heat. And also during the summertime, it's also a lot cooler as well. So try to design in those basic efficiencies that exist to begin with. In New Paltz, New York, we are required, all new construction has to be Energy Star certified. It's a more stringent standard. You have to hire a Energy Star auditor who will confirm that you're meeting all of the requirements. They also will do a model of the house to say, well, how efficient is this house to begin with? Now, this house was modeled at a -1 HERS index, meaning it was net zero. HERS stands for Home Energy Rating System, and it looks at all the systems. It looks at the insulation. It looks at the air infiltration and a few other things to come up with that index. So this is the design method, right? Modeling your house to know how efficient it is kind of a starting point in today's world for building a new house. I forgot to mention that even though I'm talking about a new house, many of the things that we'll talk about tonight are applicable to remodeling as well. They are, everyone's furnace will eventually fail. Everyone's hot water system will fail. Windows eventually need to be replaced. So all of these things are relevant to remodel as well. Of course, when you're building a house, you get the opportunity to think about all of these things at the same time. So one of the key things you want to do in planning the house is to orient the house to the south for solar gain and also for solar energy for your solar panels. And that means getting the roof sized to be able to fit the panels you need, as well as getting the pitch of the roof optimized so that you pick up the solar rays. You optimize the electricity that you're going to produce by maximizing the exposure of the sun's rays to the panels. And as the sun moves across the sky during the year, there are different angles that are optimal. Generally speaking, you want to pick sort of between somewhere between June to August time frame to get the pitch of the house, the pitch of the roof to pick up the sun's rays in the June to August timeframe. Generally, June is what the preference would be on that. So the other thing that we have to sort of, confess right up front is that when you're building a house, you're going to clear some of the site. So you're digging a carbon hole, right? You're losing some trees, and that's a bad thing. So you really want to take down the fewest trees possible. That means saving the mature trees and the healthy trees and taking down the small trees and the fewest number. But the reality is you still need to clear, you do need to have some clearing, because otherwise you will lose some efficiency from your solar system. But there is a point of decision making where you say, how many trees do I really want to take down? The picture on the right shows, it's probably about a 150-year-old oak tree, and it's a beautiful tree. I concluded that it would be a crime to take that tree down, even though it does interfere a little bit in the morning hours with the sun and the solar panels. It's just, again, it's a trade-off. Why lose such a beautiful tree just to gain a little bit more from the solar energy that you can generate? So that's just an example of, yeah, that's a compromise we're willing to make, and it's a beautiful tree. Let me just see if there's any, I'll pause. Let me just see if there's any questions about designing standards and site itself. All right, I'll move on. So microclimate, right? Where do you live? Not that we can control the weather, but the climate that we're living in is going to influence what we build. And of course, the climate is we're seeing greater extremes because of climate change. And that needs to be taken into consideration. What kinds of things? Well, the number of days of sunshine, right? How many good clear days do you get? If you don't get enough clear days, sunny days, it's going to be difficult to reach net zero. So some areas are better than others for solar energy. New Paltz is pretty good number of sunny days. It's not like Arizona, but it's certainly pretty good. Unlike Arizona, right? We don't have a lot of days that are over 90 degrees. Although that number of days is increasing for us because of climate change, we're getting more 90-degree days. And so the need for air conditioning is actually going up. Although you can reduce the need for air conditioning by some simple methods, using a cupola for ventilation. Just putting a ceiling fan in every bedroom is another simple thing that you can do that reduces the need for the number of air-conditioned days. The other extreme on temperature is how cold does it get? The reason why that's important is because heat pumps, which is one of the primary technologies that we're using nowadays to be fossil fuel free, heat pumps begin to lose their efficiency when they go below 20 degrees Fahrenheit. The technology is getting better and better, but your heat pumps extract heat out of the air, and if there's not a lot of heat in the air, they have to work harder and they'll run longer to get that heat out. We're seeing fewer cold days. That doesn't mean we won't get a week or 2 weeks of particularly cold weather. So that's just a reality. It's something to consider. I'll talk a little bit about how I dealt with that in a future slide. And probably the other thing to think about is the rain. How much rain are we getting? are we getting too little rain and we're seeing drought? Or are we getting big rain events? We just had 2 big rain events in a row in New Paltz. And so I think in New Paltz, we're a lot less worried about drought than we are flooding. And I actually know it's something that I need to do a little work on. We actually had a little pooling of water. So, so how much rain should influence your design, could influence your design as well. So that's the microclimate. So the next really big thing that everyone talks about is what they call the building envelope, and also consumption, right? If you can reduce your consumption of electricity, that's sort of the best thing that you can do. Doesn't mean that we can get our consumption to zero, and doesn't mean we don't want to be comfortable, but being conscious of showers, right? I mean, do we take 20-minute showers or do you take 5-minute showers? If you're a teenager, you take 20-minute showers. It seems like they do. Thermostat settings, right? Where do we want to set? What's the temperature that we want to set? The thing about very super tight homes is that you don't need to set the temperature as high because there's less cold air infiltrating the house. So it's more comfortable because there's less breezes, less chills in the air from infiltration. So you can lower the temperature during the winter and keep it a little less cool during the summer. Finally, the square footage of the house, right? And in our case, well, we did want to leave this option of the B&B. So our house is a little bit bigger than perhaps what we would need to live in. So that consumption is sort of the starting point. How do you reduce your consumption? The building envelope is the next big thing that you need to focus on. And there are so many different ways to build a house that has high insulation factor. In fact, there's probably dozens of ways you can build a house. There's one method is called a double wall. Another method uses a SIP, structured insulated panel. There are houses made from straw and clay. There's so many different ways to build a house. Although, they have different costs, access to materials, and access to skills, people who actually know how to build them, is difficult. The more unique you get, the harder it is to find somebody to actually do it. So in my case, I kind of did a little bit of a compromise. We used a traditional stick build framing, wood framing, 2x6s. So it can hold more insulation. We did use a spray foam because that gives you a very tight seal. And then we also put 2 inches of foam on the outside of the building. And that combination gives you an R25 wall. It gives you a good thermal break. Those 2x6s aren't exposed directly to the outside. So the foam, the 2-inch foam, creates a thermal break between the exterior and the interior. And that's one of the things you want to try to do, is to have fewer materials that conduct the cold into the house. And finally, because you're using the spray foam, you're really sealing every little crack and possible place where air can get in. I'm going to pause here for a moment and just see if there's any questions about the walls in the house, because there are so many different ways to do it. Any questions?
I'll jump in with a question. Janelle here. I've been in a group that studies the global warming potential of refrigerants. And in that group, we also learned about the fact that one should be aware of the global warming potential of your spray foam, that not all foams are the same. They may have the same R value, but it's really important to ask a lot of questions or research it, because actually a lot of foam installers don't even necessarily know the answer to that question, but it is something to really consider when you're putting foam in. Is that something you learned about along the way as well?
It is. There's several different kinds of foam. Most of them are petroleum-based foam, and one is called open cell, another is closed cell. They have different insulating factor, but there's also foams that are soy-based foams now as well. So this technology continues to mature, and I would say it's moving away from petroleum-based foams. It's still the dominant solution, however, I would say, the petroleum-based foams, but it is evolving still.
My understanding is it's actually the propellant that you need to be concerned about. The propellant is the greenhouse gas.
That's right.
Yeah.
So there's the propellant, and then there's what is the material of the foam itself.
Right. We do have a few more questions popping in the chat. Amanda asked, what is SIPS and what is ZIP?
Okay, so SIPS, SIPS, stands for Structured Insulated Panels. And what it is, it's a factory-made panel, and basically it's a sandwich. You have plywood on the two outsides and a thick layer of foam in between. So those are made in the factory. They come in large sheets, and you basically construct your house out of this sandwich of foam, basically foam and particle board or plywood. So that's a construction method. It's highly efficient. It's very quick. It's more costly. But it also gives you a really good tight seal, because there's no 2x4s, there's no internal structures. The panel itself is the structure. ZIP, I'm trying to think what ZIP, I don't know if ZIP stands for something. It probably does. It's a manufacturer's brand name for whether the exterior board that goes on your house. So it's basically sheathing. It's the sheathing of the house. Zip board, it may stand for something. I can't recall the name of it. Zip board prevents water and air from penetrating the house, and it's sealed very well. So it's a product that is available, and it's called Zip. I don't know if it stands for anything. All right. Janelle, any other questions?
I guess Amanda was asking for more clarification about the foam. Is that styrofoam? Or Amanda, do you want to pipe in with a more detailed question?
Just wondered if rigid foam was something like, I don't know what rigid foam is. I know what spray-in foam is, and I know what fiberglass insulation is. And then
So the rigid foam, which is, I think it's polystyrene, is the rigid foam. That's what's used in the SIPs. It's also what's used on in my case, the Zip boards also are polystyrene.
I'd like to also jump in and just say that I heard recent presentations about, even if you are using the fossil fuel based polymers, that some of them have a lower embodied carbon than others. And so sometimes you might choose to have thicker versions of a lower R value because it's got a lower embodied carbon in how they make it, as opposed to using kind of the highest R values and only needing, an inch or two of that. So that's part of the equation.
I think they refer to that as whether it's open cell or closed cell, and you get a different R factor from using open cell versus closed cell. And now I'll have to dust off my research on this as to which one is better. Is it open cell or closed cell?
Well, I think cell tends to be a higher R value, but I think it also depends on whether it's which polymer it's made out of, whether it's polyurethane or polypropylene. I can't remember the specific details, but I've definitely seen a few presentations on this recently, just within the last year.
Yeah, it's an example of it's a really good example of a trade-off, right? Which is, okay, this product, spray foam, right, gives you a very high insulated house with low infiltration because it's sealed, but the material itself isn't necessarily the most environmentally friendly material either. So it's an example of a trade-off between, hey, what's the best solution here? Is it better to use rock wool or fiberglass, blown fiberglass? And there is a lot of, and this is an example of where there's just a lot of debate in the industry still. I would say that spray foam is very popular, so you'll find a lot of people doing it. And of course, that's part of, hey, can I get the job done? Can I find somebody to do it? We used roof trusses and also spray foam here again. And because the roof trusses are so open, you're able to use a lot of foam. And that gets you a very high thermal resistance, an R49 roof, which is where you lose most of your heat, is through your roof, not through the walls. It's a low cost. It's a good cost, and it's also a quick way to build a house with trusses. So those are some of the reasons why you might choose trusses. And then finally, we chose to use a concrete slab. Less concrete goes into the building. That's goodness, because concrete produces a lot of greenhouse gas emissions. So the least amount of concrete that you use is better. And we use 6 inches of rigid foam underneath of it to create an R26 insulated slab. Again, this is a topic that you could have a 1-hour meeting just on building envelopes, because there's so many different approaches you could take. And that's a good thing to have a lot of variety. Although I would say the building industry does try to find a common solution so they can optimize for lowest cost. And they're not necessarily optimizing for lowest greenhouse gas emissions. So that's an example, right, of where can we influence the builders on the selection of materials.
So we have a good question.
Yep.
Sorry. We have a good question here from Amanda that I imagine others are thinking, and that is, did you make all these decisions yourself, or did you rely on a special contractor? It might be very daunting for people to make these decisions. What do you recommend?
Yeah, that's a really good point. Now, I did a lot of personal research myself. So in my case, I did the work to look at all the options and consider them. But and your if you have an Energy Star auditor, they too, and if you hire an architect, they also, and if you hire a builder, they'll all suggest different things. So you tap into all of those people's knowledge. Your architect should be the most source of authority on how to design an energy efficient building. This industry is changing so fast that even not every architect knows the latest trends. So even, some of your own research is perhaps needed, but you can rely upon your energy auditor, your architect, and your builder to understand what are the latest materials and what are the options. in my case, I did a lot of the research myself. Windows and doors. Windows and doors are the things that we love, right? Because they get us to the outside and they bring the outside in. But they are very costly and they degrade the envelope of the building a lot. And that's even if you're using the most efficient windows, triple glazed windows. Windows can be tremendously expensive. Many of the most efficient windows are coming from Europe, and that means they're putting on a lot of miles to get here. Although there's a lot of good window manufacturers here in the US now as well. You know, the basic rule is minimize the total square areas, total square feet of glass and penetrations, doors and windows. That's the rule. Don't put in more windows than you need. The reality, of course, is that that's hard to do because people like to let in natural light and they like to have the view. So it's a real compromise, and that's, again, to the aesthetics of the house. You know, what is it that is going to be pleasing, but not overly inefficient either? So, you know, that's the windows are a double-edged sword. They create lots of beauty, let us take in the outside. They also let lots of heat escape the building. All right, I'm going to move on unless there's some other questions. Okay,
Can you
yeah.
hear me?
Yes, go ahead.
So I have a question about, this is me seeming to be mostly about building a new house.
Yep.
So is that really a good idea? Because, you know, if you're trying to save resources, reusing things, homes, clothes, whatever the case may be, is less wasteful than buying or building new things, shoes, clothes, homes, whatever it is. And it seems, so where does the payoff come when you have all these people building all these new houses as opposed to using an existing house?
Yep. So, you know, that was my first, I jumped ahead to my closing thought page because it's my very first comment, which is that, you know, building a house, a new house, is a little bit egotistical, right? You're saying, hey, let me cut down all these trees and bring all these materials together to build something that suits me, right? So it's kind of egotistical. But on the other hand, right, what if no one builds any houses? How many people will not be employed, right, in the trades and in the manufacturing sectors, right, if no one builds any new houses? We'll have a different issue, right, if we don't build houses relative to employment. And the last thing that we have to consider, right, is if we don't increase the stock of housing, if we build no new housing, we are only going to have existing houses, meaning that, well, they're going to become more expensive because there's only so many houses. So there is a need to add to the stock of housing done in the right way. And that's part of the message of my presentation is, well, if you're going to build in a way such that it's really efficient, you get to net zero energy and don't burn fossil fuels. And that's the best kind of a house that you can build. Now versus, well, okay, if you just take an existing house and remodel it, that's fine, but there's no new stock of housing being added, so housing will intrinsically become more expensive with no new construction. And the people who work in these industries, builders, manufacturers, they will not have jobs. So it's a complex problem, like most things in the world today. It's a complex problem, and you know, we're not going to stop building homes, but we need to build them smarter and not contribute to global greenhouse gas emissions in the new homes that we build. Homes represent the homes, meaning the heating, cooling, and hot water, is one of the largest contributors. It's next to transportation. Transportation is the highest contributor to greenhouse gas emissions. Our residencies are the next highest thing that produce greenhouse gases. So I hope that answers your question. It's not a perfect answer, right? Because, hey, you did take down some trees and you did have to incur all of the transportation miles to bring all these materials together to build a house. But it's a good question. And it's an appropriate question for everyone to be conscious about when you're getting ready to make the decision. Should I build or should I remodel? Electricity. Producing electricity is one of the key ways that you get to net zero. Because if you don't produce electricity, if you just consume electricity, you're not going to get to net zero. You'll be dependent fully on the grid. So we tried to size the grid, size the solar system to achieve a net zero energy. So we, over the course of a year, we produce as much as we consume. Of course, and you'll see this in the metrics. Well, we don't produce that much electricity during the winter, and we produce a lot more electricity during the summer. So it's not balanced. The system itself, we are grid connected, 13.6 kilowatt photovoltaic array, 44 of them. And we have that requires 2 inverters. For those of you who are techies in the crowd, what the inverters do is they convert from DC, direct current, which is what the panel, the solar array produces as direct current, and the inverters convert them to alternating current, AC. And AC is what your house runs on. So that's what the inverters do. And it also, they let you feed the grid because you now have a AC, alternating current, and that can go out onto the grid. We also have one battery, a 17 kilowatt battery. We decided to add the battery because we did not want to add a generator that would be gas powered or propane powered. So we just use the battery for our backup energy, and we don't have a generator. And the auto transfer switch is what's used to consume the battery if the grid goes down. We drive the system programmatically to keep the battery charged. We then service all of the loads, the electrical loads that are in the house real time. And then finally, any excess electricity feeds the grid. And by feeding the grid, particularly during the summer, the local Central Hudson, right, can use my electricity to burn less coal and less natural gas. So I am helping them by using a renewable resource, the solar array. So those are the key components of the electrical system. We've done a couple of other things. We've separated out the critical circuits, and the critical circuits are what get backed up from the battery. So if we lose electricity, we don't lose the well. We're able to continue to have water in the house because it's running off the battery. But you don't want every circuit to be running on the battery because the battery won't last very long. I'll just close, and it gives us about 24 to 48 hours of backup electricity. That's not perfect, right? You can be without electricity for multiple days from a really severe storm. So it's you could add more batteries, but we've decided that this is where we would draw the line. The other thing that is important is the question of, well, is this economical, right? Does this really make sense economically? And the answer is sort of. Yes, I'm paying the electric company less, the utility company less. But it's still expensive to put this all up. And the payback, in my estimation, is somewhere in the range of 10 to 20 years in reality. Now, it could vary because, well, you may have more cloudy days, or you may have more sunny days, or you may have more colder days or more hot days. So you may be using more electricity than you're producing. So it's somewhere in the range of 10 to 20 years. And the reason why I bring this up is because we have to think of our houses as investments. And they're investments that, they're going to be here. They're going to be here for 200 years, 300 years. Just like the Huguenot houses just like the stone houses on Huguenot Street, for those of you who know New Paltz, housing can be around for 200-300 years or more. Europe has some very old houses. Our houses need to be thought of in that way. They're going to be here for 200-300 years. Let's build them as they are investments. And a 10 to 20 year payback is not in reality that long of a time. Now, in a person's life, it may seem like a long time, but in terms of the life of the house, it's not that long. I'll just stop here for a moment and see if there's any questions about the electricity in the house.
There was a number of comments, and anybody is welcome to just unmute yourself and pop in a question.
Yeah, I'm not looking at the chat, so I can't see what they are.
Okay. For example, how much of that 16,500 kilowatts per year are you using?
So it depends on what's happening, right? If you think about during the winter, you're heating the house, but you're not making a lot during the winter. If you have snow on the panels, you're not making very much. During the summer, you are using, if you're running the air conditioning, you're using a lot of that. So I would say that it's the extremes, the extreme cold and extreme hot days when you're not making enough. But on all of the in-between days, you have plenty of energy. You're making enough of your own energy. You don't need to use the grid. That it was sized for kind of the average. The extremes, extreme cold days, extreme hot days. When it's extremely cold, it's probably snowy and your panels aren't producing very much. On extremely hot days, well, hopefully there's good sunshine, but you may be running the air conditioning more. So you have to look at this, and there's in the metrics, I'll show you some of this. The right chart is not there. You really want to look at how much did you produce this day, and how much did you use this day? So on a daily basis, did you produce more or did you consume more? And I can tell you that during the winter, you're definitely consuming more than you're producing. And then during the summer, it's inverted. You're producing more than you're consuming.
One of the, kind of paraphrasing a number of questions and comments here has to do with the love that people feel for heat pumps. And I imagine that you're coming to that next. And also
Yes.
comparing other supplemental sources of heat, such as wood fuel.
Yep.
So perhaps you're coming to that next?
In fact, that is the very next chart. So if you're not using electricity to heat or cool or make hot water, then you're probably using oil or propane or natural gas. So we took those fuels.
We can't hear you.
I think maybe your internet's unstable, Joe. We couldn't hear you there. Can you repeat that sentence?
Yep. So if you're not using electricity, then you're probably using oil, propane, or natural gas, and maybe wood. Some people use wood, right? So we took all of those out, and we rely exclusively on heat pumps. And we use that for heating, cooling, and producing the hot water as well. The comment I would make, in the very beginning, I talked about the microclimates. Heat pumps are great, when for anything above 30, 40 degrees Fahrenheit, really about anything above 30 degrees Fahrenheit, heat pumps are really efficient. It's when you go below 30 degrees Fahrenheit that you start to lose efficiency. And that just means they're going to run more to produce the heat that you need. So they are, and they keep improving the heat pumps. So this is a technology that keeps getting better and better, and it's going to probably continue to get better and better for some time as well. The other fuel that we use is gas, and we have minimized. We haven't gotten rid of our use of gas, but we're getting close. I have a 20-year-old gas lawnmower. We use it once a year to cut the meadow down. I have no lawns, so we don't mow, and we have a lot of pollinating flowers, which is, I think, very attractive, and also we don't use the mower. We have wired our garage, so planning for an electric vehicle. We all should be thinking about, where will the electric vehicle be? How do we get electricity to it? And this is true for remodeling as well as new construction. We ought to be thinking about, what will we need to power the electric vehicle? So we haven't made the leap yet, but our next car will be an electric vehicle, and we're ready for it. We also got rid of the gas-powered generator. So we're getting there, but we haven't quite gotten to zero. Cooking is another place where people use gas. For those of you who enjoy cooking, you'd probably say you like cooking over natural gas best. I know my wife does, but we were committed, and we said, okay, we're not going to have any natural gas, no propane. Let's make the jump to an induction cooktop, which is the most efficient form of electric cooking, is with induction. So we made, we made that change. And again, for your next stove, even in remodel, think about using an induction cooktop. Finally, wood. You know, I remember my comment about aesthetics. Well, who doesn't like a fireplace, right? Fireplaces are certainly very attractive, but they're very inefficient as well. So we searched around for a sealed fireplace for the ambiance. We also wanted to have a backup heating capability because, well, our battery may not last. So the battery will only last for 24 to 48 hours, and we don't have a backup generator. So the fireplace is sort of like the last resort for heating the house if we need to. It's not terribly efficient. And so we don't use it regularly. We use it really just for occasions and for the ambiance of it. It's in a modern house, it is frowned upon, actually. In a brand new house, the Energy Star auditor will put a big frowny face on that part of the design. But again, these are decisions that we have to make. And we get pushed and pulled in a number of directions. Janelle, any questions on fuel, different oils and fossil fuels?
Well, several of us are commenting to each other in the chat regarding another plus with induction cooktops that really should be mentioned. Since a home like this is so well sealed, not a lot of infiltration, it means that burning gas causes indoor air pollution, which they have found to be much more significant than was previously told. So that is really a consideration above and beyond even the greenhouse gas issue. Its health is switching to induction.
You know, Janelle, a lot of people will say, well, the reason why you have a hood over your stove is to get rid of, fish smells. Really what you're doing is you're getting rid of the volatile elements from burning gas. That's one of the key things that you're doing with a hood, an exhaust hood over your stove. So you're absolutely right. It's not burning any fuel is definitely healthier for all of us in the air quality of the house. I would be remiss if I didn't talk about water because it's fundamental, right? So we don't live, the house that we have doesn't have the ability to connect to the town water system. So we didn't really have a choice. But I will say this, if the opportunity was there, we probably would have taken advantage of connecting to the town water supply because you create such a critical dependency for electricity when you're on your own well. So generally speaking, if town water is available, I would recommend using it. Wasn't an option for us, so we do have our own well, meaning, and we also have, of course, that means we have our own septic system and leach field. We minimize how much water we produce with wastewater we produce with dual flush toilets and low flow showers. And finally, we do rainwater harvesting. It's being implemented for the purpose of watering our gardens, vegetable gardens. And you can see the tank on the right. That's a 1,000-gallon tank, and all of the water coming off of the roofs are collected into the cistern. And it does fill up during these big rain events that we have. That tank can fill right up to the top and then overflow. So that's an example of a luxury that I would say, you probably really don't need it. In our building, we wanted to show what are the technologies involved, and you know and depending on where you are, rainwater harvesting can be very important. If you're in with the volatility that we're going to see in the weather, we may have years when we're in drought. So will we need to be prepared for droughts is something that we have to consider. So we decided we wanted to do this to show the technology. And when I say technology, there's very little technology involved here. It's all gravity for the most part. So that's a good thing. Speaking of technology and automation, Janelle, how am I doing on time, Janelle?
Let's see here. We have another 25 minutes.
All right, I'm just about done, so I want to save time for questions. So I'm going to go kind of quickly to the rest of this then, so we can get some more questions. So internet and automation, it's become indispensable, the internet, right? We all want to be connected, whether that's good or bad, right? There are days when I think it's bad, but generally speaking, we all use the internet. And I use it to monitor the systems and to control the systems. So that's one of the benefits. That's part of a smart house, is to monitor what's happening in the house. But what I have found from previous experience is that you can go too far with this. Automation that's based on motion and voice activation, it adds very marginal benefit and a lot of complexity. So having lights turn on or off based upon there not being any motion, especially when they're LED lights, you're not getting that much out of the additional cost and the complexity of having motion detectors in rooms. Although that said, I do have some lighting in the house that is motion based. So it's not, I use it sparingly in a few places. Automation based on day and time offers a lot more utility, and it can be effectively used to reduce consumption. Think like thermostats and a few lights. And as I said, I use the internet to connect my devices and to see my consumption, both water and electricity, and I'll show that in the end. Even though our house, right, is technically, the house doesn't, food is not part of the house. That said, we produce CO2 indirectly when we go to the store to get food and when we have stuff delivered and acquire stuff. So how can we reduce the need for food? Well, what can we grow ourselves? So planning for a garden, again, whether this is new building or remodel or not even just remodel, just putting a garden in. What are the foods that you like? How do they get good sun? Will they get good water? Planning for all of that. Produce the foods that you will consume that you like. You won't satisfy all your needs, but again, if it reduces some of your dependency, that's a good thing. We commented earlier about building, and that, a new building, it requires lots and lots of things to be brought to the site. Flooring, doorknobs, wood, all of these materials are largely not produced locally. Some of them are, but the reality is very little of it is produced locally. But if you look around, you will occasionally find something that is produced locally. And so you have to really shop for the materials that you need. But it's very hard to find the materials that you need to build a house just locally. So the reality is you're going to be bringing in materials. When we brought materials in, we tried to select materials that had high recycled content to them. Our siding has a high percentage of recycled content. And also, is the material easily recycled? So our metal roof, obviously, is very easy to recycle once it needs to be replaced. It's a 50-year roof, so we won't be replacing it anytime soon. But once it does need to be replaced, it is material that can be easily recycled. So that's one way to compensate for all the transportation greenhouse gas emissions that we're creating and building the house in the first place. So again, there are trade-offs, and think about having your own garden. Think about using materials that have a high percentage of recycled content. We also do compost, so planning space for where will the composting go. How can we recycle this mountain of cardboard? So I became very diligent about recycling all my cardboard, and I think I got to know the recycling center people on a first name basis, because I brought down a ton of cardboard to recycle, and we've kept that ethos. It is hard to get to zero waste because the products that we buy are just not packaged well enough to reduce the waste, to fully reduce the waste. So it's really going to require a lot more work with the producers to minimize the waste. And finally, I would just say, I'm getting ready probably next year over the winter. I'm going to start to track the pounds of waste and recycled materials that we produce. You can't reduce it. If you don't track it, you don't know how you're doing. So we want to begin to track what our output is on waste. And that just leads me into the metrics. I'm a big fan of metrics. And here you see the energy production by day. And we're looking at, this is kilowatt hours per day. And we're looking from November 1st, 2020 to, I took this on October 29th, 2021. So basically a whole year. And the blue and the green just represent the two inverters that we have. So they both produce electricity, AC. And what you see in this chart is, well, during the winter, from November through end of February, you're not producing that much electricity because you have snow, depending on what's happened, right? You may have snow on your panels, or it may just be overcast and you're not getting much sunlight. And then as spring arrives, you start to produce, you start to get a lot more energy production. So all the way through, September and October, it starts to diminish in September. The sun is lower. And so those trees that you didn't take down begin to have more of a detraction on your energy production. So that's, this is the energy produced. Central Hudson just recently changed the accounting system, so the account numbers. So I can't get a good history of my consumption. And I'm trying to pull all that information together to show the production versus the consumption. Water usage by month, it's pretty stable. You tend to use a bit more water during the summertime. And if you're looking at October and you say, the last bar there. How come you consuming more water in the month of October? We are putting in a no-mow lawn. And so to get the seed started, you have to water the seed. So even though we had a lot of rain in October, we still had to do a little watering. And finally, the garbage and recycling is something that I want to begin to track. So I've already talked about the egotistical nature of building a house and whether or not is it still a good thing? Well, yes, it does employ people. It does it helps to manage the affordability of housing. The other 3 points are conversion to electric heating, cooling, hot water it makes it very complementary with the solar energy system. The two go together very well, and to achieve net zero, that's really what you have to do. Plus, you need to take a long view on the payback. We still ended up with a very complex system, right? This is not, there's still lots of things, although we don't have that many pumps and moving things and things that burn. But we still have, we did reduce the complexity by eliminating certain things. For instance, we actually considered using recycling showers, where each shower gets 5 gallons of water and it recycles that 5 gallons of water and it heats it, and you keep getting, you're not putting hot water down the drain. We looked at that technology and we concluded that it was not ready for mass market. And so we took that off the list of things we were considering. And zero waste is very hard to achieve. It won't happen unless we get changes both by the producers and the consumers, and tracking is really important. Whether you're a residence or a commercial business, we should be tracking our waste more closely. So Janelle, I'll stop here and just open it up for any questions.
I wanted to connect just for a second on your issue of the shower and recycling the water. So a solution that we do at our home, which we love, is our outdoor shower. Yes. And it's a black tube that holds about 5 gallons of water, which is about enough for a quick shower. And in the summer, we shower more because we're gardening, etc. It's hot. And it's so awesome to take a shower outdoors, and then all the humidity just goes outside too. So it's less to air condition. And then the water we collect for our garden. So it does get recycled in that way. So we certainly love that.
You're producing the hot water with solar hot water heating, and then you're recycling the water for your gardens. That's very commendable.
It was a sad day yesterday when I determined the freeze is coming and I must take down my solar shower, because we enjoy that. One of the questions that have popped in the chat is, do you use a geothermal heat pump?
Yeah, we looked at that. In New Paltz, there's a lot of shale and there's a lot of boulders, and drilling for geothermal is very challenging. So it really depends on the geography in your area. The other thing to keep in mind, and I'm not a huge fan of geothermal, because even if you do geothermal, you bring the water temperature up to about 55.
We're losing you.
We can't hear you there. Actually, if you can hear us, if you can stop sharing, and then we can all see each other, and different folks can join in the conversation here.
Plus, the other thing about geothermal, which I'm not a fan, as I said, I'm not a fan of it, is it has a lot of pumps and there's a lot of complexity to it. So I've stayed away from geothermal for all the reasons I just mentioned. But if you live in the right area, it can be a good solution.
So I stopped sharing the screen just so we could see each other right now. And I wonder, join in, anyone with a solution maybe you found or a question that you may have for Joe.
I don't have a question. I just have a comment there. Dear friend of mine who's now deceased, who's a teacher up at New Paltz in the printing department, and he built a foam dome. I don't know if you're familiar with it. Well, his name was Bob Schuler, and it's in High Falls. And if I can get a photograph of it, I will.
It's called
It's
a foam dome.
A foam dome, a geodomestic dome, I think they call it.
I think that's, yes, it's just all foam. There's no, and it's free form, which is very interesting. I mean, it's not structured like a square house. Yeah, it's just, it looks like something out of The Hobbit.
Yeah. So Ralph, this is a really good example, right? At the very beginning, I talked about aesthetics, right? Some people would really say, I love that house. Look how like a Hobbit house, right? Other people would say, oh, I don't want to live in something like that, right? There's not enough windows in it, right? So we're all kind of influenced by this question of aesthetics. And sometimes it's a very strong force, and sometimes it's not such a strong force. And deciding what's important, what is it that motivates you? Is it energy efficiency, or is it, hey, I want this certain look and feel? Is some of the decision making that goes into it.
Constance, did you have something to ask?
I do. I have a question. So I have floor radiant heating, and I'm really interested in using solar to support my floor radiant heating.
Okay.
But I know, like heat pumps, you said they're so efficient above 30 degrees Fahrenheit, but we have pretty harsh winters, so many days are below 30. So what do you really feel about heat pumps being in an area where we're below 30?
So the first thing to do is get the actual data. Get the data. How many days below 20 degrees? Because it's below 20 degrees Fahrenheit when they begin to start to be inefficient. And it all depends on the equipment. So you have to look at the efficiency curve and the area that you live in. How many days are below 20 degrees Fahrenheit or below 30 degrees Fahrenheit? So get the data together first.
Can I jump in and just say that there are now cold climate heat pumps. I actually have one. They heat at full efficiency down to minus 13 F. So,
oh, wow.
And they keep working actually down to minus 50 F is where they really shut off. So you can, if you ask for what's called the cold climate heat pump, the one I have at least works really, really well in it's a very tight envelope space. So I think you have to make sure you work on the envelope of your building and make sure there's not a lot of air leakage. But if you're in a really good tight space, they work very well in this climate. I mean, it's just as cold, I think, where I live as it is where you are.
They do work. The cold climate heat pump does work. They just work harder to produce the heat. So it'll still generate heat. It's just going to have to work harder to get the energy out of the air, because there isn't that much energy left in the air. But the technology does keep improving, and you're absolutely right. They have made great improvements, and now heat pumps are usable pretty much into the coldest climates.
Joe, I also want to comment about the geothermal heat pumps, which I think are more efficient in the colder weather. And we have one here in New Paltz, and we're really very pleased with it. And it's going on 4 years now, and so far everything has been pretty good.
Yeah, and I wouldn't consider New Paltz a particularly harsh winter. And maybe it used to be harsher. It hasn't been very harsh in a while.
If we get a polar vortex this winter, we'll be calling you, Joe. Mark Varian has been patiently waiting. He's got his hand up.
Hi, Joe. I was just wondering, do you expect to get actual numbers from Central Hudson or just net numbers?
No, I do get from Central Hudson actual consumption, but because they recently changed the accounts, I don't have my history anymore. I have a new account number, and I only have one billing period of history. So when I tried to go get the history, I couldn't get it. It's online, but it's under the old account number, which I can no longer see.
But that's just billings. Isn't that based on net?
They show me both.
Really?
Show me what I actually used and what I contributed. So what did I net? What was the netting of the two?
Thank you.
We have Lighthouse Solar, and they have a nice online app you can use to really track it all. I could get really immersed in that some days, looking at the details. Oh. Other questions?
I see Amanda's got her hand raised.
Yeah, I think there's a Central Hudson account you could get that showed you sort of what Janelle's talking about. It shows you your usage like almost real time. You had to pay extra per month for it.
Yeah, and you need the right meter, right? You need the
Yeah.
correct meter to have that two-way reporting of what.
Right. Otherwise, it just gives you the net, like you're saying, Mark, the difference between what you used and what you fed into the grid. It gives you the net.
Right.
But there was I just didn't pay for it because I just didn't want to, but there was another way to do it.
No, it's good to know. I didn't know that.
Yeah. Or you can do like Janelle said, in your inverter system could tell you, but I didn't get that one either.
That chart that I showed is off of my inverters. What did I produce?
Yeah.
I should mention here, there must be some people on this call that are energy navigators. Liz was on this call. I don't know if she still is, but we should let people know that the energy navigators can be a good place to go if you're in a position, maybe not doing a new build, but you want to do some upgrades and need some guidance. Are you familiar with the energy navigators, Joe?
I am, and you know, so every time we have the opportunity to change our homes, right, whether it's windows or furnace or where can I put a garden in this year, right? Everything that I talked about today can be applied to remodel as well, or just living, right? So, but being conscious of it, right, and knowing what the options are is sort of the starting point. These are new things that we have to consider and reflect upon. Let's, how do we not burn oil or propane, and how do we convert to electricity?
We've had, I have to tell you, this has been a great a meetup. We had, unfortunately, a few people that couldn't even get in on the meetup. The link didn't work from the meetup platform, but I will circle back to them with the recording. And any of you that would like to get the recording, maybe you missed part of it, if you zip me an email, and I'll put it in the chat, to New Paltz Climate Smart, then I can get you the recording too. But I really want to thank you for giving everyone food for thought on, what maybe is the next project they want to take on in their home.
Janelle, can I just say something?
Yes, please.
Oh, good. Hi, everyone. This is something it's so very important. If you are thinking about upgrading to a heat pump or installing solar panels, please make sure the very first thing that you want to do is an energy audit on your home. You need to see what your current building envelope looks like. And if it needs to be improved, you need to do that before you spend money on any other upgrades, because otherwise, I mean, I've seen people, they'll put, you know, a large solar array on their home and they'll put heat pumps in, but they had nobody look at their building envelope. And then when you tell them they need $15,000 worth of insulation, they freak out. But your systems are not going to work well if you don't have energy efficiency and your house isn't weatherized. So please do that first. New York State offers a free energy audit for homeowners. You can go to NYSERDA's website and look up their energy auditing program and find a contractor in your area and get that done for free. So at least you have a baseline. And you should always try to get a blower door test and some energy modeling done in your home before and then after your improvements, so you can see what was done, and save all your documentation for any improvements that you do on your home, because when you turn around and you get ready to sell your house, you're going to want to be able to show that to the next homeowner so you can market the house better and get some more money for the improvement that you made.
Marcy, would you say windows are sort of like the starting point?
I would not touch windows at all. I mean, most people's windows are fine. You just have to air seal them really well, because as you mentioned earlier with windows, they have such a low R value. So even if you replaced it with a better low E, double paned window, you're still really not gaining that much. Your improvements are so much better off just improving your building envelope from the get-go.
Right. That's a great point, right? Windows are inefficient by default.
And everybody thinks, oh my gosh, my house is so drafty, I must need new windows. And I tell you what, your sound, barrier, you might have a quieter house after you get new windows, but if you don't seal up everything else, forget it. It's still going to be as uncomfortable as it was before.
And a low-tech solution for windows that have a lot of conduction, short of replacing them because they're so expensive. And insulated curtains. Curtains make a big difference.
Or just put some of the shrink wrap on it in the wintertime. Those that, believe it or not, makes a big difference.
It really does, indeed. Yeah. Marcy, are you able to put in the chat a link to that NYSERDA website to find? I think that would be helpful to a lot of people to let it come up. Amanda, you have a question.
Well, a couple of things. One is what I found is my windows are great. It's the seal around them that the contractor didn't put good, sealing around them, so I can feel cold air around them. Also, Central Hudson was providing rebates on some of these things because they would love for you to go all electric. So they've been helping out. And does anyone know if there's still the federal and state tax rebates for like solar panels and some of these other things? They're still there?
Yes, absolutely. And the heat pump, the clean heat rebate program is great. I would suggest that if you are thinking about it, do it sooner rather than later, because there is a finite amount of funds that they've released for those. And they have already reduced it once, I think last month. And there could be anticipated reductions next year. And the program just may run out of funding. So if you're thinking about it, do it, but get your energy audit first.
So I was just sharing this information with somebody on the chat, but when we were looking at doing solar, we have our electric usage from our bills. And so we talked to Lighthouse and other solars, and so they could calculate how many solar panels we would need to replicate that. And then they bring this, like, it looks like a Frisbee, I don't know, they bring it out and put it on your roof, and they can tell from your direction of your roof and your angle and all this thing, like how much efficiency you're going to get and how many more units you need to accomplish what you need, you're trying to replace. So they can tell you how many panels you're going to need to try to produce the electricity you were using before. And
that Frisbee that you described basically is representing the path of the sun through the whole year, when it's low in the horizon versus high in the horizon, and how much sunlight will actually meet up with the slope of the roof and the location, the orientation of the roof.
Yeah, and then we decided that even though the trees were shading it, that cut on our cooling, so it was a trade-off. a trade-off, yeah.
Marcy's just put into the chat the link to the NYSERDA website with the energy audit options. I would suggest clicking on that before we close the Zoom, and then you'll have a tab open to that site. And she's also putting in another one for clean heat. So that may be very helpful to folks as well. And do know that we have these meetups once a month, every month. We've been doing them now for a couple of years, and we have not covered the same topic exactly the same twice. We always come up with new things. So I would encourage you to get on our newsletter mailing list if you're not already. Make sure I have your email. We'll add you to the newsletter. The meetups are always the first Tuesday of the month at 6 o'clock. So the newsletter comes at the end of the previous month or the beginning of the month. And so it's always the first thing front and center in the newsletter is the next meetup. We also have a Climate Smart book club that has a high bar in that we read a new book every month if we can, or listen to one is what I do. This next month we're reading the book that's kind of the sequel to Drawdown. And it's a book that you can easily, it's called Regeneration. And it's a book that you can easily tackle just in sections, maybe not even read the whole book, but just take the parts that have appealed to you. And that Climate Smart Book Club is the third Tuesday of the month at 7 o'clock. I do see that we have a question here to Joe from Marcy. Who is your architect for your new construction?
So the answer is the woman architect in Gardner, New York, Hoover, I think it's Hoover Architect. But I think she would probably say, well, Joe, you brought me the design for the most part. I pretty much knew what I wanted, but she drew up all I worked with her, and we collaborated together, but I pretty much brought her the design that I wanted to execute. But Hoover, and she was great and had lots of good ideas. I think it's just Hoover Architecture.
By the way, Joe, there's a green building registry that you can register your home in. Have you done that yet? You did. Okay.
I am. Yes, I'm on it, and I got my rebate from NYSERDA.
Good. Good. And in case everybody there is this thing called the Green Building Registry. If you want to try to find homes in your area that have any type of energy efficiency certification, you can go on that registry and look to see who your neighbors are that have really cool energy efficient homes. So,
that's awesome. I didn't know that existed.
I'll find that link for you. I'll stick it in there.
Okay, perfect. And I need to let Joe go here. We're at the end of our time, but I really want to thank everyone for participating, offering your comments, your questions. And I definitely got this recorded for you, so I can send copies to those who want more information. Be sure to click on the links in the chat before you go so that we'll retain this. And I'll look forward to seeing you all again in the next meetup or book club. And I hope that you've also been inspired by Joe's story to maybe share your own personal story. We've had several people come on these meetups and talk about, transformations they did at their home, either in terms of a renovation or a new build, as in Joe's case. So, and many of us have skills that can be shared that everybody has. So we're wide open to anything that might be considered climate smart. If you've got an idea for a meetup, do let us know, and we'll feature you next month, perhaps.
Thanks everyone for being such a great audience, and I hope it was both interesting and fun.
Let us know when you're offering tours.
Okay.
Janelle, that's something we should put together, is a green home tour. Like when we all are not so freaked out about a COVID, that would be really fun to do.
I totally agree. I think it might even be possible to do it, even just kind of a walk around a house to talk about a sense of place and, the features, even if we can't do a walk through. There's a lot that can be shared too, just in terms of landscaping green.
Yeah.
So yeah, great idea, Marcy.
Or maybe some of our new build, there's commercial and municipal buildings that are becoming green. So those are,
Yeah, we should go to Zero Place. Check it out.
oh yeah, that was cool. But Angry Orchard was done by Matt Bielecki with some of these. Now I know what the SIPS thing is with that kind of construction, and some other places too. So there are places you don't even realize. You can't tell by looking at them.
Now we just need a green bus, a bus that's
Yes.
an electric bus.
What was it? Phillipstown just went electric school bus.
Oh,
Is
yay.
that right?
Good for you.
Awesome.
Yeah.
Yeah.
Wow, that's fantastic. Well, thanks once again, everyone. Really appreciate
you.
you all.
Have a good night.
Well,
Evening.
Bye.
Thanks, Janelle.
Indeed, my pleasure.